Today we're talking about center of mass. We've already talked a little bit about center of mass, so some of the first couple of items kind of make sense. The location of the... I don't know why I'm blanking right now. Okay, so the location of the weighted average is because I didn't read this part. The center of mass is the location of the weighted average of the mass of the system. The entire mass of a system is compressed to a single... Some people say single point, but I say single mass blob. Alright. We talked about how if an acrobat's like spinning in the air, flying around, that we just care about that central mass point. The single point to... It's the single point that balances all of the mass in a system. It's a single point to do that. It balances the whole, all the masses. And so if I've got mass 1, 4 kilograms, at position 0, mass 2, 4 kilograms, at position 6, that would be two 4 kilogram masses located 6 meters apart. So let me just draw it. 4 kilograms and 4 kilograms. Oh, that's not 6 places apart. That's 5 places apart, huh? Let's put them 6 places apart. 5. So x2 equals 6. x1 equals 0 meters. This would be 10 meters. Does our number line system make sense, kind of, sort of? All right. Not crazy. All right. Where do you think the center mass would be located? Oh, this is easy. All right. XCM equals 3 meters. Why? Well, the masses are identical. Yeah, equal. So the balance point or balancing point or balance point is in the middle. Directly in the center. All right, so then they're going to give us two unequal masses. Small mass, big mass. So we have 4 kilograms here, 20 kilograms there. Location of item 1 is 0 meters. The location of item 2 is 6 meters. Around where do you think? Give me a range of where it could fall. 4 to 5, somewhere around there. My official textbook answer says we know that it's greater than 3 and less than 6. And so X would be between 3 and 6 is what I end up. Oh, you can't see what I wrote. I said X is between 3 and 6 is my official answer. We know that if they were equal, that it would be smack dab in the middle, right? We already wrote that. So instead of being smack dab in the middle, we favor the heavier mass. Right? That makes sense. My long answer, this is me just typing or writing out short notes. My long answer would say if they were identical, it'd be in the middle. But now, because they're not, we'd favor the bigger side. So how do we actually do the math behind this? It's a weighted average. I think that's what we said at the very top of the page, right? And so our weighted average is going to be the fact that XCM is the fraction of the system mass at position 1 times its position plus the fraction of the system mass at position 2 times position 2. What each one of these items individually does is it tells us what percent does it contribute to where the center of mass will be. Okay. And if I have a third mass, I could, keep adding the fraction of system masses. That's only supposed to have 3 dots for ellipses. And that would give us our center of mass position. All right. So XCM, the fraction of system mass. What's a better way of writing that?
That mass over total mass.
Right. M1 over M total. Where do we find this kid? Where's this kid been hiding? And then fraction of mass 2 over the M total. X2 plus so on and so forth. M1 is different than M2. X1 is different than X2. What could we factor out, though? The total mass. And so we're going to factor that out. Math class says that I could have M1 X1 plus M2 X2, but everything has the mass total. Even if I included a M3 X3 or M4 X4, that would all be added into it. And so let's see if it actually works out for us. If I have, and I'm looking for XCM, of everything that we have in scenario 2, we would have said the fraction of the masses, so M1, what's M1? Times position 1, 0, plus 4 times, no, it's not 4. What is this one? 20? 20 times 6, all over 4 plus 20, right? That's the total mass. So 0 plus 120. Oh. You're saying I've been working in space for this whole time, even though I've been recording? This is awkward. Alrighty, so I add 4 times 0 plus 20 times 6, all over the total mass of 24. Is 120 divided by 24. What do we get? 5? So at 5 meters is my answer. So our true answer is 5. All right, let's look at the next one. The next one asks us, does this equation work even if everything is shifted over? And so the problem is nearly identical, except now we have 4 kilograms and 20 kilograms, but they're still separated by 6 units apart. Does this work if we're shifted over on our number line? x, that's 0 meters. This is 5 meters. This is 10 meters. This is 4 kilograms. This is 20 kilograms. This location here is at x1 equals 4m. Alrighty. Where do you think it's going to be? You should know this. It should make sense. Where are we? 9. We're just 1 over from the 20 again, right? We know that. That's where the center of mass between the 4 and the 20 should be. It should be 5/6 of the way down this number line between the two. But does our equation tell us that? What is our equation? Let's write that out first. We should probably write out that we have m1x1 plus m2x2 all over the total mass. That's the center of mass between two objects. We could do 3 or 4. But it's 4 times 4 plus 20 times 10 all over, what's our total mass again? Same, 24. 4 times 4 is 16. 20 times 10 is 200. So I've got 216 divided by 24, and that should equal 9. You could double check. Type it in the calculator. It's also just 24 short of 240, right? That's the quick maths behind that. Compare similarities between 2 and 3. I've been pointing to them. What are they? Write them down. What do you notice? What's the same between problem scenario 2 and scenario 3? Same distance between them. Same massful objects. Same masses of the objects. What's different? Yeah, just our relative position of the number line. Honestly, we just shifted our number line over. Okay. In the notes from 2 days ago, it said that we can look at center of mass independently in the x, y, and z axes. And so now we have a two-dimensional problem. We've got a mass, 4 kilograms at 0, 0. I've got a mass at 1 and 3. I've got a mass at 2 and 5. And I know that this is not an isosceles triangle. This is not an equilateral triangle. This is not even a, I don't even think this is a 3, 4, 5 triangle. I think this is kind of like off a little bit. But I know that the center of mass should be somewhere around here, right? I drew an X around 1.8. 1.8. That's just my rough estimate. It just asked us approximately where do you think it is. So I just kind of drew a triangle and I said, hey, look, that's probably the heart of the triangle. If you said it was 2, I think it's a little too close to the top, but you know, that's up to you to figure out. So it says solve for the horizontal center of mass, then solve for the vertical center of mass, right? There's separate components, so we could say m1 x1 plus m2 x2, and now we're doing a third one, m3 x3. What do we divide it by? The total mass. m1 plus m2 plus m3 is xcm. That's how we find the center mass. M1 position of X. I think all the masses are 4. So 4 times 0 plus 4 times 1 plus 4 times 5. I just went straight down the row of X values. All over 4 plus 4 plus 4, and 4 times 3 is 12. 4 plus 20, 24. Divided by equals 2 meters. Sorry, not 2 meters. In this problem, they didn't assign it units. It's just 2, unitless. I don't know what the scale is. It's meters, centimeters, inches, feet. Doesn't tell us. I would have assumed it to be meters. If you put meters in your answer, I'm not going to be mad. What are we going to call what does it say to call this? Y, cm? So the center mass of Y. And the masses are all the same. 4 times 0 plus 4 times 3 plus 4 times 2. And I just went straight down the row of these. 0, 3, 2. And we're going to divide it by 12 again. If I were to rewrite the equation, let me do that real quick. That y cm equals m1 y1 plus m2 y2 plus m3 y3. But then we're going to divide out the mass to just leave us with the okay. That way you don't take off points for me missing my equation. I just want to make sure we have that. Went back, filled it in. 12 plus 8. 12 plus 8 is 20. 20 divided by 12 reduces down to 6. 10 sixths. 10 sixths is the same as 5 thirds. 5 thirds is 1.67. So my coordinates are 2, comma, 1.67. I'm going to go ahead and give you the answers to number 5, scenario 5. You could try this on your own. The equation's the same. You plug it in and it works. But why does it work? Where are your coordinates, everything happening out? I got 3.24. You can try it. Comma 2.06. You can try it. Read through it, solve for it. That's the coordinates that I got. Here's the way I think about it. We have a small mass, same coordinates, medium mass, and it will greatly favor this large mass over here. Okay, because it's more than half of the whole system. Okay. So that's the way I think about it. You can try it.